This is part 14 in a series of videos in which I'm attempting to repair an HP9830A desktop calculator. In the previous videos I've carried out a lot of repairs, but unfortunately it became apparent that the ROM card was damaged, or several ROMs weren't working, and because they're not really replaceable, I've had to take the decision to create a replacement ROM board. Now, I've designed the ROM board. You can see the silk screen for it here. I've got them on order, and as soon as the boards arrive I'll get a couple made up and I'll be able to then start further testing on the machine. This is very typical with machines of this era, where typically in repairing them I spend more time creating methods to repair than carrying out the actual repairs. However, I've designed this board in such a way that it can be used for development of firmware, custom firmware for the machine, as well as obviously running the standard firmware. And I will be making these available on my website if anyone wants to take advantage of them. Of course, having the ROM card is one thing, but I now need the code to put into the actual ROM. It's not much good having a ROM card with no firmware. If you're familiar with this machine, you've probably seen the patent for the machine that was filed by HP when the machine was first designed. It's about 600 to 900 pages depending on which version you get, and it does include what's supposed to be a full listing of the firmware. Now, this is the assembly listing, so it's commented, and it does contain the instructions and the line numbers, along with the descriptions of each instruction and descriptions of what each part of the code is supposed to be doing. So it's quite useful when you're trying to trace through the operation of the machine, but it's not much use for trying to recreate the hex code that I need to put into the ROM. What I need is just the hex values in the right order for this third column. But as you're also probably aware, this is a PDF document, so I can't just easily cut and paste it. You can OCR it, carry out a conversion process to try and extract the images as text. This particular PDF appears to be a series of scanned pages. It would be nice to get hold of the original documents, but I can't find that anywhere. So it looks like the only approach I can take is to OCR the document, turn it into text and go from there. The problem is that when you do that, you end up with a document that looks like this. OCR is it's not infallible, and especially because the scans are not particularly high quality, you can see there's an awful lot of basically nonsense and rubbish in this file, and also it's not all in the right order. Some of the OCR processors stripped the data out as columns and put that into the file sequentially rather than in the right places. So it is a bit of a pain trying to go through this manually, and there are of course thousands of lines of this. I did start going through this trying to extract the information, but it became a very tedious process, and it was obviously going to take a very long time to complete. So what I did is similar to what I showed in the previous video, where I've written yet another piece of software. I'll just give a quick demonstration of it now. It looks similar to the previous software, and it does a similar sort of thing in terms of it parses the data files to try and create a more meaningful file. But the way this works is you select the file that you want to process. So this file I've selected is the one that we're looking at in the background. Give the file a destination file name, and then I have various options. I'll leave it in the sort of default form for now and just click on process. If I now open the file that creates, then you can see what it's done. It is gone through the file, it's identified the line number in the file. This is not the instruction number, this is the line number in the file, where it's identified a meaningful instruction address, and then it's trying to find the matching instruction itself. And if you saw the text that popped up with the software, I'll just run it again. You'll see it down here, it's said error. It comes up with the invalid line number, line too long, but I've just done that because that's generally the main failure. But I've also included the line number within the file to indicate which particular part of the file is at fault, because the line numbers in the file and the instruction line numbers don't tie up, because obviously there are comments in here and blank lines and errors and rubbish in here as well. So if I now open the file directly, so if you look at line 123, we can see that it's identified this as being at fault because the instruction number doesn't have enough digits. It's only 5 instead of 6 digits. So the next thing to do would be to correct this, and that means I can go through the file and it will identify obvious faults like this. It won't tell me if a misscanned instruction is correct, but I can start looking at that later when I start trying to debug the code once I've got it reprogrammed. But the main thing is to try and get the major bugs out of it and try and make it match the original patent as closely as possible. That's the first purpose of the software. It allows me to look for obvious faults in the file. But once I've done that and corrected all the faults, incidentally I can turn off the stopping on error and just process the entire file. It'll run through the entire file, and we then end up with the entire file ready to read. So this is now the entire contents, and it's gone through, and as much as it can, it's identified the lines that don't have errors. But of course we need to make sure that as much as we can we've removed all the errors. So what I can do is go through, get rid of all the errors, and then I can turn off line numbering and addresses or whatever combination I want, reprocess the file. When I now look at the file, it has just the instructions in, so I can compare that directly against what I've read out of the board and also what's in the patent, and try and get some consensus as to what the correct value is. And then I can look at the actual instruction values and decode them and see if it makes sense. Once I've done that and it all makes sense, then the final step is I need that information in hex. It's no good to me in octal, I can't put that into the ROM. So what I can do now is select the hex format. I can also invert the data, which is what's required for the ROM, reprocess the file, and what I end up with now is a file that's in hex format, and I can now use that and load it into my programmer. So if I open that particular file, this is now the inverted hex version of what was in the PDF. I haven't gone through and corrected all the faults yet. I'll need to do that while I'm waiting for the boards to be delivered. And once I've gone through, corrected all the faults as much as I can, I'll program this into the ROM, and that'll be the starting point for debugging and see if that takes us any further forward in the repair. Okay, hope you found that interesting. As you can see, the repair of this machine is turning into a bit of a saga, but hopefully I'll get it working eventually.